Once again, our home plate for tonight is pages 348 and 349, evens only. Okay? Well, unless you want to do all of them, that's up to you. Extra practice. There's only 13 problems in there. But if you do evens only, then you only do... Very good. All right. So, our objective for today, I can identify rational zeros of polynomial equations. I can identify rational zeros of polynomial equations. Once again, I can identify rational zeros of polynomial equations. Now, the main concept is polynomial equations, but it's under the umbrella of what? Polynomials. And by now we know the definition of polynomials, yes? Yes. Tell your neighbor the definition of polynomials one more time. That is correct. Monomials, or some are different than monomials. And these are some examples of polynomials. And these are non-examples, so on and so forth. All right. So I'm going to take a step back just to make sure you understand the objective. Today's objective is that we identify rational zeros. So let me first clarify zeros. Okay? Write your attention down, look up to the screen. So according to what we did before we went to break, I gave you an equation, and there was one of these in the final, by the way, that looked like this. F of x equals x squared times x plus 2, and I said graph that polynomial function. The process to graph that, I said, you make this equal to 0, factor that. So now that we have three factors, we set them all equal to 0. X equal to 0, x equal to 0, x plus 2 equal to 0. Solve, minus 2 minus 2, x equals negative 2. So now that I have these, I can graph. In order to graph, we need to know what it looks like. So, how many x's do I see? 1, 2, 3. That means the parent function, this parent function looks like this, x cubed. What does a graph of an x cubed look like? It looks something like this. Where does it start? Down here, and it goes all the way up there. So that means it starts down here, and it ends up where? Up here. So let's see, let me plot my point, 0. Another 0. I'm going to make it bigger so I know that's a double one. And my other one is what? Negative 2. All right, so here we go. Go through that. This one, do I go through it? No, I barely touch it. And I come back up, and there it is. All right, Mr. Q, what does it mean by zeros? Well, let me take you back to 8th grade. Those of you that were with me. I said all of these are known as x-intercepts. They are also the solution. They're also known as zeros or roots. And many of you, Mr. Q, do we need to write that? Yeah, so you can memorize the names of them. We still haven't clarified why are they called zeros. Let's find out. Because if I was to substitute any of these three numbers in here, what does that give me? 0. Yes, that is correct. So watch, I'm going to write this. X times x times x plus 2. And instead of x, I'm going to use for right now negative 2. Negative 2 times negative 2 times negative 2 plus 2. So let's see. Negative 2 times negative 2 is 4. What is negative 2 plus 2? 0. What is 4 times 0? 0. So what does that give me? A 0. That's why these are called zeros. So what would happen if I substitute these? It's going to give me what? 0. Any questions with 0? We good? All right. The other term is rational, because once again, the objective says identify rational zeros. Now, rational we covered on the very first day we were in school. You guys remember that? Yes, Mr. Q. All right, good. I started with real numbers, and then we covered rational. So before I move on, tell your neighbor what a rational is. What's a rational? All right, looks like Cindy Cardenas has all the answers today. Let's see. What? You were saying that you had it. All right, pass it to someone. Chelsea. Rationals. They are? Very good. Numbers that can be written as fractions. Example, 23. How can I write it as a fraction? 23 over 1. Let's see, another example. How about Danica? Wow. 24. Yes, 24 over 1. How about 0.25? Trying to narrow the fraction form of that one. 1/4, and so on and so forth. Yes? Yeah? Okay. All right. So those are rationals. So we already know what zeros are. We already know what rationals are. So according to our objective, we're identifying rational zeros of polynomial equations. So think about it. Rational zeros. What do you think that means? Think about it. Talk it over your neighbor. See if they know what rational zeros are. At least have an idea. All right. Good combo. Let's see. Colton, I saw you paying close attention to Monza's definition of zero or rational zeros. What did she say rational zeros were? Okay. Monse, what were you saying? Substitutions here for the zeros could be written as fractions. That is correct. That's what we're going to be looking at today. So these, instead of writing them like these, they could be also what? Fractions. Damn, cool. All right. So this is how the book introduces this lesson. Ready? Here it goes. Rational zero theorem. If p of x is a polynomial function with integer coefficients, and if m over n is a zero of p of x, which is p of m over n, which is equal to 0, then m is a factor of the constant term of p of x, and n is a factor of the leading coefficient of p of x. You got it? Yes. So basically what it means is this. If I give you a polynomial, equation, to find the rational zeros or the possible rational zeros, I need the constant and I need the what? Leading coefficient to get started. That's basically all it means with all the wording. Some of you are like, what are those, Mr. Q? What are those? Well, if I was to give you the polynomial x squared plus 5x plus 6, tell your neighbor the constant of that polynomial. 6 is correct. The number without the variable. Tell your neighbor the leading coefficient. That is correct. 1 because it's the number that multiplies the first variable of the first term. What is that number? It's an invisible 1. So those are the two pieces that we need, and that's how we can write our what? Rational zeros. Mr. Q, I still don't see the fraction. Let me show you. Constant over leading coefficient. That makes a what? A fraction. What is my constant? Leading coefficient? 1. And that's how we can get started. A little bit clearer than this? Yes? Yes, Mr. Q. All right, copy this one. Example 1. You copy the instructions, at least for this one. They're going to be the same for the rest. It says, find the rational zeros of a polynomial function, semicolon. Then write the function as a product of factors. F of x equals x cubed plus 2x squared minus 19x minus 20. Copy that, and I'll get started in a little bit. All right, here we go. I'm going to get us started. I need you guys to stay focused. I'll have you copy a piece, and then we're going to do another piece, and then copy that piece, because it's a lengthy process. So everybody go like this. Bear with me. Here it goes. So to get us started, according to the rational zero theorem, we need what? The constant and the leading coefficient. So I'm going to write that over here on the side. Constant and leading coefficient. So by looking at this polynomial, what is our constant? Negative 20. There it is. And what is our leading coefficient? 1. You're like, that's it, Mr. Q? That's to get started. Now, check this out. Pay attention, please. The next step is imperative, which means importance. We need to find all factors of each of those numbers. I'm going to start with 20. What pairs of factors give me 20? 1 times 20. 2 times 10. 3 times nothing. 4 times 5. And that's it. And 1 is 1. Okay. So to find my possible rational zeros, I need plus minus. What is 1 divided by 1? 1. 2 divided by 1? 2. 4 divided by 1? 4. 5 divided by 1? 5. 10 divided by 1? 10. And 20 divided by 1? 1. Copy that. Okay, show me what the current faculty you are up to right there. 5, 5, 5, 5. Okay, yeah. So once again, to get started, possible zeros, what do we need? The constant and the leading coefficient. You write it as a rational or as a fraction, find all possible factors and all possible combinations to give us those possible zeros. So what are we saying, guys? That all these could be zeros. What does that mean, Mr. Q? Well, let me go back. That all of those could be, we can set them equal to 0 and solve, and that could be our 0 for the equation. How many possible? All those. All right. So which one do you think is the 0? We don't know unless we do what? We find it, yes? How do we find it? Using synthetic division. Writing your pencils down, look up to the screen. Here we go. So, to get started, I'm going to test this one. One times 1, 1. Combine, 3. 1 times 3, 3. Combine, negative 16. 1 times that, negative 16, combine, negative 36. Did I end up with 0? No, that's not my 0. Next, 2. 1, 2, negative 19, negative 20. All right. 2 times 1 is 2, combine 4. 2 times 4, that's 8, combine, negative 11. 2 times negative 11, negative 22, combine, that's negative 42. That is not a 0. What do I do next? 4. 1, 2, negative 19, negative 20. 4 times 1 is 4. Combine, 6. 4 times 6, 24. Combine, 5. 4 times 5 is 20. Combine, that is, well, guess what? We just found our 0. So let's see, how do we write it? What do I have left here according to the home play last night? X squared plus 6x plus 5. And what is our possible 0? X minus 4. Copy that, please. All right. So we found the first 0, which is 4. Yes? But according to what we have here, look up, guys. What is the highest degree of this polynomial? So how many possible zeros shall we get? 3. Which one do we have already? This one. So we need how many more? 2. That means we need 2 more factors. Look at this. Can we get factors from here? Yes, tell you never how we can get factors from this. You got it, Cindy? Victor, go. Oh, Power Rangers. That is correct. Yes, the big X. Thank you, Victor. So 5 goes on top, 6 goes on the bottom. Factors of 6 that add up to, factors of 5 that add up to 6. 5 and 1 are 1 and 5. So I'm going to rewrite this. Bring down the first term, x squared. Instead of 6x, what do I write? 1x plus 5x. And then bring down the last term, which is 5. All right, group. GCF here is x. I'm left with x plus 1. GCF here is 5. I'm left with x plus 1. All right, so what is the same here and here? X plus 1. What's left? X plus 5. And what's our other? X minus 4. And all that equal to f of x. Now, since I gave you the practice earlier in regards to zeros, do you see the zeros now here? Yeah, we set it equal to 0, and then we can set each of these equal to 0 to find our intercepts. Okay? But up to right there, I need it up to right there. Okay? So let's see. Look at the whole process. We started off with a polynomial function or an equation, and they're asking us to find the possible rational zeros or rational zeros, and then write the function as a product of factors. This is product of factors because we have 3 factors and they're multiplying that product. All right, what did we start with? Our constant and our leading coefficient. Find all possible factors, and that's our possible rational zeros. We started testing one by one till we found one that was with a 0 remaining. Once we got that, we got the second part, we factored that, and we found our other 2. Okay? Show me your parents officer you are up to right there? Yeah, it's lengthy. I know it's work, but Got all the different pieces that we've been practicing, yes? And of course you did your homework last night. Very good. All right, copy this one. Example 1Q. G of x equals, you don't need the instructions anymore, you should have them already. G of x equals x cubed plus 7x squared plus 16x plus 12. And once again, we need to find the rational zeros, and then we need to write the function as a product of factors. So let's do this one together. What do we start with, everyone? Constant and the leading coefficient. So what is our constant? 12. What is our leading coefficient? 1. Factors of 12. 1 times 12. 2 times 6. 3 times 4. And all that over 1. So my possible rational zeros are plus minus what? 1, 2, 3, 4, 6, 12. And once again, where did we get those from? Well, what is 1 divided by 1? 1, 2 divided by 1, 2, 3 divided by 1, and so on and so forth. So now that we have our possible zeros, we need to check to see which one is a zero. How do we check? Using, there you go, synthetic division. So let's get started. We got 1, 7, 16, 12. And all that, we're going to divide by 1. The first number always comes down, straight down, and then we get started. What is 1 times 1? 1. What is 7 plus 1? 8. What is 1 times 8? 8. Combine these. 24. 1 times 24. 24 combined. 36. Is this a 0? Nope. Miguel, what do I do next? Use 2. 1, 7, 16, and 12. Miguel said to use 2. Bring down the 1, and let's get started. What is 2 times 1? 2 combine, 9. 2 times 9, 18 combine, 34. 2 times 34, 68 combine, that's 80. Is that a 0? No. What do I do next? Allie. Go with 3? All right. 3. We got 1, 7, 16, and 12. Allie said test 3, so let's see. Bring down the 1 again. 3 times 1 is 3. Combine, that's 10. 3 times 10, that's 30. Combine, that's 46. 3 times 46, that's 138. Combined, that's 150. Is that 0? No. Who sees it? Thank you for the number. What do I do next? Let's see. Allie. Pick someone. Fernanda. What do I do next? Negative 1. And we're like, where did we get negative 1, Mr. Q? Well, aren't all these plus minus? Let me repeat that again. All these are what? Plus minus. Now, if Fernanda said negative 1, let's find out why. We tried positive 1, it gave us what? At the end, 36. Tried positive 2, it gave us what? 80. Positive 3, it gave us what? 150. What do you guys notice out of the remainder? It continues what? Growing. So that means what's going to happen if I try 4? It can be a bigger number. So that means now we need to try what? Negatives. Bam, Fernanda in the house. Remind me of me, kindergarten. 1, 7, 16, 12. Bring down to 1. Negative 1 times 1 is negative 1. Combined, that's 6. Negative 1 times 6 is negative 6. Combined, that's 10. Negative 1 times 10 is negative 10. Combined, that's 2. Is that a 0? No, but it's getting close. What do I do next? Roberto. Negative 2. 1, 7, 16, 12. Negative 2 times 1 is negative 2. Combined, that's 5. Negative 2 times 5, that's negative 10. Combined, that's 6. Negative 2 times 6 is negative 12. Bam! What did we find? Our 0. So what do we have left? X squared plus 5x plus 6 times, what is our 0? X plus 2. Am I done? Oh, tell your neighbor what the next step is, please. Like Victor said, factor with Power Rangers. 6, 5. Factors of 6 that add up to 5. 2 and 3. All right, so let me rewrite this. This is x squared. Instead of 5x, I'm going to use these two. Yes, remember these? 2x plus 3x. Bring down the last term. Oh my goodness, why? Group, they bug, don't they? X plus 2. GCF here is 3. We're left with x plus 2. So my factors are x plus 2, x plus 3, and x plus 2, and all that equal to g of x. Let's go. How are we doing? Somebody in the family how come you are with these? Yeah, we got these, yes? 4 5s, 4 5s. Okay. Let's see. Crank it up a notch. Yeah. Yes. Copy this one. Example 1, super duper cube. The function given is t of x equals 2x cubed plus 11x squared plus 17x plus 6. All right. Let's see. Fernando went last. Fernando, pick someone. Ponce, get us started, please. Constant over leading coefficient. What is my constant? And my leading coefficient? 2. So, factors of 6. 1 times 2 times 3 times 6. Yeah, 1 times 6, 2 times 3. Yeah. And the other one is 1 times 2. Okay. So let's find our possible rational zeros. Plus, minus, let's see. Look up, please, so you can see it. 1 divided by 1 is 1. So I did this one with this one, yes? So now this one with this one. What is 1 divided by 2? 1/2. Did everybody see that? I did this one with this one, and that one with that one. Okay, comma. What am I doing next? 2. What is 2 divided by 1? 2. What is 2 divided by 2? Everyone? 1, but we already have it, so we don't need to rewrite it. So we're done with that. Let's go to the next one. 3. What is 3 divided by 1? 3. What is 3 divided by 2? 3 over 2. And the last one. What is 6 divided by 1? 6. And what is 6 divided by 2? 3, and we already have it here. Do we know what to do from there? Yes, Mr. P. All right. Monse, pass to someone. Chelsea. Synthetic. So what do I write here? Okay, so bring down the 2. 1 times 2 is 2. 11 combined with 2, that's 13. 1 times 13 is 13. Combined with 17, that's 30. 1 times 30 is 30. Combined with 6, that's 36. Is that a 0? No. Pass someone. Roman. What do I do from there? Negative. Roman, let's go. Negative 1. So let me bring this down to 2. Negative 1 times 2 is negative 2. Combine, that's 9. Negative 1 times 9, that's negative 9. Combine, that's 8. Negative 1 times 8 is negative 8. Combine, that's negative 2. Nope, that didn't work. Pass someone. 1/2. 2, 11, 17, 6. Bring down the 2. 1/2 times 2 is 1. Combine, that's 12. 1/2 times 12, that's 6. Combine, that's 22. 1/2 of 23, that's 11.5. Combine, that's 17.5. That's not 0. Pass someone. Negative 1/2. 2, 11, 17, 6. So negative 1/2 times 2 is negative 1. That gives me 10. Negative 1/2 of 10, that's negative 5. That gives me 12. Negative 1/2 of 12 is negative 6. And guess what? Let's go, Maria in the house. So what do we end up with, Maria? Plus 12 times x plus 1/2. And I'll stop right there. And at the end, we know how to factor this, yes? Good one, guys. Enjoy your home play. Once again, pages 348 and 349. Evens only. Good one. See you guys tomorrow. Bye.